So our GPUs combined with the recent announcement of our enterprise AI stack really providing a lot of tools and infrastructure, and AMD is really centered on openness. That's kind of really significant for us, and that's what we're doing is working with a lot of ISVs, software partners like Kamiwaza to basically, again, make it easier for organizations to adopt the technology. And when you look at what's happening with AI and you look at what businesses want to do with AI, there's a lot of different workloads. How many people here use AI on a daily or regular basis? Okay, the vast majority of you. You know, it's funny because when I was coming here, I actually had my car drive me here, and I was just like, oh my God, like I'm using AI again, in addition to all the work things that I do. But when you look across all the different types of applications, there are a lot of the common ones, chatbots and so on, but there's also a lot of specific things like in life sciences and other areas, financial and more. And businesses are trying to sort of figure this out. Like, what are we going to do with AI? Not only that, but they also need to know the how part, right? And so how is this going to be implemented? And what we think is very likely to happen is organizations will have a number of different applications that you see on the top here. Some of those they'll create themselves. Some of them they will leverage tools from various partners or open source or whatnot. And they're going to want to run these across homogeneously, if you will, whether it's on-prem or with a neo cloud like a Vulture and others, or at a mega data center company, or maybe a mixture of all of them, right? So this is sort of the picture of what is really required, what we need to deliver and set the table, make it easier. And that's really our, this is the entire AMD stack. You saw a picture from Linda showing this in the Supermicro color scheme. But this is the same basic picture here where we are providing our foundation software, ROCm. One of the things that I think many people don't realize about ROCm is our foundational software tool, and most of the applications that are written are in PyTorch and these popular frameworks. How many people know that ROCm is the only other software package that's totally upstreamed and supported in addition to CUDA? So now you guys all know, literally, AI developers do not need to stop doing what they're doing, right? If they're writing in PyTorch, if you're using JAX, TensorFlow, all these frameworks, AMD ROCm is completely upstreamed and supported. So you don't need to use anything different. You don't need to learn a language. You can target AMD Instinct GPUs by using ROCm. And Supermicro has servers available for remote access. So if you ever want to do it, you have that ability. So ROCm is our foundation software, and then above that is what we introduced, part of our AI enterprise stack. That's where partners like Kamiwaza fits in, and that allows us to get into the various models and the enterprise applications. So just a quick snapshot here of what ROCm is. Again, I use this term foundational software, and it really is. It's the nuts and bolts. It's the bottom of the stack, if you will. It's directly interfacing to our hardware. And so it's providing all the interfaces that are needed so people can use these frameworks and really squeeze the performance out of our GPUs. And then above that, of course, you have all the different inferencing type tools, and AMD works with a large number of these open source and open models and software tools. And then again, as you move up, you start to become and build the various enterprise type applications. And so I just want to give you a quick snapshot on what was announced and released by AMD. So this was something that we had introduced to the market. We've been working on it for quite a while, but about 3 or 4 weeks ago, this was introduced. And there's a lot of different components to our enterprise stack, but basically these are tools that really allow enterprises to more easily adopt Instinct GPUs. And so kind of from the bottom up, the workload management, this is a real simple GUI. I'll show you on the next slide. It just shows you how efficient are your GPUs being used, and it has some simple knobs and switches to allow you to more efficiently do some deployment. We have some fine tuning, our AI workbench, which is a fine tuning algorithm suite. Again, there's some simple GUI to make it very straightforward for you to squeeze the more efficiency and more throughput out of your models. And then we have microservices, which we're bundling things together. So our AMD inference microservices, again, for starting points. And then above that, we actually have blueprints, which are example designs. So AMD has half a dozen designs right now, like there's an FSI design, healthcare, and RAG, and so on. And you can download all these. This entire stack is open source. So AMD is going to continue to update this and develop it, but it is readily available. And a lot of what I'm talking about here is all on GitHub already. And so just a quick snapshot before I turn it over to Luke, who's actually going to explain to you in better detail than I can what they're doing to enable organizations to not only seamlessly adopt and target our technology, but make sure that all the data security and the rest of the ecosystem is all provided for. But this is just our resource manager, and you can see here, it shows you the number of GPUs, percentage of deployment, and so on, to give you kind of a window in of how efficient, and do you need more GPUs, or can you deploy more effectively? And then our workbench, again, this is a very straightforward tool. We want to provide a level of abstraction so you don't have to know everything about how to squeeze the more performance out of our devices. We're providing a few options here for you to go in and to better make efficiencies out of your AI applications. So with that, I'm going to turn it over to Luke.
Sweet. Can I get some energy? Let's get these people out there enthused about AI orchestration. Come on. All right. You guys got enthused for Supermicro. Come on, you can get enthused for this. All right, so let's have a little fun here. So first off, this is the sort of prelude back to AMD. It was a big unlock for the actual software development ecosystem when AMD finally released the Enterprise Suite. What that really did for us is they gave us the recipes to actually optimize the cards underneath. So everybody has talked about the CUDA lock. There isn't such a thing, but there is such a thing around the optimization around CUDA. And with the Enterprise Suite that they're able to bring out, with the actual recipes they're able to deploy, it literally makes the cards work sort of out of the gate. And from that, we can talk about what that optimization means and what actual outcomes are being delivered in the enterprise. But that was a big piece. The other thing I just want to talk about, because I hadn't heard it yet, the new Pro line that AMD's released has been a big piece for us as well. You're talking about $1,200 for a GPU now. You can stick 8 of them in a server, and now you can get 3 to 4 servers and actually have outcomes in that sub $150,000 range for the enterprise. And then you can jump up to the Instinct line and the $1 million plus sort of outcomes. And that's a huge difference. There's really only been an NVIDIA capability for that. And now AMD's brought that to market and made it usable. It's really stepped it forward. All right, so now what do we do, and how does this actually unlock what the enterprise actually needs? When we talk orchestration, we're talking about 2 core things here: distributed data engine and the ability to inference mesh. These are both concepts we brought to market. So the first off, think about this. You're going to have data in a cloud. You're going to have data in edge. You're going to have data in data centers. For an AI agent to actually unlock and do something, it needs to access all of that data. So now you can install our stack with AMD next to each one of those subsets. We actually scan all the data. We build the metadata of the data. We build an ontology of the metadata, and then we build an ontology for the business systems. Once you've done that, now you can redirect the inference to actually process that data, move the actual agent around on that data, and now you start to get these incredible levels of actual business outcomes. There was a lot of talk about models and how they're progressing. If you just took the model capability today, 70% of every Fortune 500 can be fully automated. You do not need another advancement in model to have a massive change to the organizations. And I'm not talking about just like Fortune 500. This obviously, with those pro lines I was talking about, can scale down into the medium and even into the small business. And once again, with this inference mesh technology, you're able to access the data anywhere. So we're not just orchestrating how you get to the data, what the data actually is, what the data means in the ontology space. We're also getting into the security of the data. But then you also have to process the data. You have to have guardrails around the data. And this eye chart is just to give you an idea on what actual AI orchestration entails. It's a crap ton. There's no other way to put it. But if you're trying to get a business outcome, it does require that quote unquote metric crap done. In doing this, though, you got to step back and say, okay, how are you actually deriving value? And the value almost always comes from the actual data side. And then how you unlock that data really comes into the security of it. We've set out to solve two major pain points in security that nobody's really thinking about until you think about it at AGI scale, until you think about it at 10,000, 100,000 clients hitting in at once, until you move past the idea of chat interfaces to fully agentic workloads and capabilities. And the biggest unlock that we had in this was this idea of reback. It was a new sort of acronym. And of course, the security world needed a net new acronym, right? It's an acronym associated with if you need to actually secure thing on the relationship. So you have a user that has this much access to data. Then you talk to an agent that has this much access to data. Then that agent then talks to a world agent that has this much access to data. But you can only have those agents infer the original user's access to data. If you don't, they're actually going to have an inference of a much larger subset of data, therefore returning answers that that person shouldn't actually have. On top of that, you have to also understand if the user is asking for two uncorrelated data sets, but the correlation, the inference of those data sets could actually raise the security. It could actually raise the answer to something that they shouldn't have. That's called the mosaic effect. And in AI, that is unlocked, and it's actually a very, very significant thing. Think about a simple HR example. If you just ask, hey, what were the option pool or what was the standard options given to an employee of a G7 status 5 years ago, and then you actually asked, how long's my boss been here, and what was the average payroll, you could actually then infer what your boss's actual salary was and what their stock options were and everything back. And you actually have to manage that and control. That was the simple answer. Now take it up to the intelligence community or the federal answer. It can really, really be a dangerous thing. So reback is where we were able to say, if we actually understood all of the data, the metadata of the data, the ontology of the metadata, and the actual ontology of the business, how do we actually secure that workflow and secure the user access? I've said ontology quite a bit. What you're actually seeing here is a graphical representation of ontology. This is the actual ontology for the Social Security Administration. When I say we do big things, I mean big things. This particular one is what's called their blue book. It's the actual ontology basis for every decision based off of every medical condition to actually see if somebody can actually get benefits and what benefits they actually should get. This process right here takes about 48 hours of 8-way large GPU system running consistently. This is roughly about 2 billion tokens of output. At the current ChatGPT pricing that Val just talked about, that'd be about $320,000 a cost to actually create this ontology. That ontology has to be reran, reprocessed every net new add of storage, every net new change of the document. Once you have that ontology, though, and once you keep that ontology updated, an agent now with standard reasoning can actually take that flow and process anything. So no more phone calls to the actual Social Security Administration. It would proactively know you immediately qualify just based off of your medical records being sent or just simply updated. It would know if your condition's advanced. It is that simple. Now, once again, this takes GPUs, it takes an unlock, it takes the actual systems, it takes optimization, which is what, once again, AMD's recipes in the enterprise systems have actually brought to us. And now we can move upstream, build those ontologies across all that data, across all locations, and actually get to a business outcome. And to wrap, which I'm a little early, so maybe I'll just do a song and dance. It's a big problem to actually deliver enterprise value. The models are capable today. It's really the data and making sense of the data that is the problem. It's access to the data. And then it's the processing of that data. And to get the processing optimized, we've selected AMD and the enterprise architecture that they've brought to make that affordable at a small level all the way up to the largest level. And with that, I'll be around for dinner. Thanks, guys.
Hold on. We have time for a couple of questions. Maybe is there anyone have a question? Yeah, hold on.
I couldn't see to save my life.
Hey, thank you. I just have a question for federated access to data. How do you keep up with the latency if you're federating access everywhere?
Yeah, that's the point. He asked how we keep up with the latency when we're federating the access to the data. That's actually the point. So the request is actually sent to the local GPU that actually processes the data, because the processing of data And any agentic RAG system isn't a single pull. You're going to have a re-rank, and you're going to pull maybe 100 to 1,000 different documents in that actual processing. So if you move the actual processing next to the GPU that's affinity to the data, like physically there, that process is going to run so much faster. And then you're only going to send back the results. And the results could be sent via a smoke screen. You're talking kilobits of data, and it's only a one-time send. And that's why you can actually sparse it out to multiple locations, process all locally, and then just send back the answers to that original piece. From a latency perspective, we've even tested this at federal government stuff to the point of like actual deployable field operations, like literally the back of a Humvee, and then you have your MOB back in DC. And the fact you could process those two data sets and keep them synchronized with very, very small packets in between sent over Starlink, I think we've done it at the most extreme levels, let alone what we've done in the enterprise. Good question, though.
Hi there. Enterprise value. What is being promised now that when going into enterprises, they're going to be able to do XYZ that they weren't able to do before? And what kind of case studies are out there that show, hey, we went into this enterprise, they got this technology, and now they can do this that they couldn't do before? What are some of those that are maybe a little bit more common?
At Kamiwaza, the actual name means superhuman or godlike capability. It's not just about what you're doing today. It's about what you could do if you had 10% to 50%, 10x more staff. So when we're working with the enterprise, once again, once you've built that ontology, you can actually start to do things like manage your treasury forecasting system. Campbell Soup is doing this to add $10 billion. And you can actually figure in hundreds of Monte Carlo simulations and literally have CPI index forecasting so you can manage that. At Health Bus Systems, we're integrating billion-dollar payroll systems and health insurance systems and actually rebidding them every quarter off of the latest capabilities, because once again, the agent could process this. So it's really about what is the next frontier. If you had literally 10x the amount of staff, you can move that right into the AI. And then you can move back to sort of the more simple processes that are within the enterprise. Our website has hundreds of examples you can look at that with.